Welcome! Let's talk about functional suitability, the core of software quality. In this video you'll learn what functional suitability is, how to make sure your project achieves functional suitability, that is, how to design and test for functional suitability, and why testing alone is not enough to confirm its achievement, the metrics you should collect in your project. We'll also talk about functional suitability in agile development, how to ensure suitability even with multiple iterations. I share the most common pitfalls I see in consulting and assessments and give you tips to avoid them. Finally, I'll give you a practical checklist to put everything together. I'll share a real example from the automotive domain, a headlights ECU, to make everything more practical. My goal? That you can use what you learn right away. Just a recommendation, don't jump to the checklist right away. If you don't know the basics, the checklist won't help much. So learn the concept first and then use the checklist. This works much better. I'm Giuseppe, I'm a principal assessor and instructor in Automotive SPICE. On my channel I share the knowledge I gained as a software developer first and as a consultant, Automotive SPICE assessor and trainer later. I am a beginner in YouTube, so if you find my videos useful, drop a like. This keeps me motivated. I also appreciate your comments and questions. Ready? Let's dive in. What is exactly functional suitability and why is this the foundation of software quality? Before we even think about performance, security or other important quality characteristics of the software, ask yourself this. Does your software actually do what it's supposed to do? If the answer is no, the software is not suitable. That is where functional suitability comes in. It's the foundation of software quality. It measures how well your software provides the required functions, meeting stakeholders' expectations. If you're familiar with the concepts from the first video, you recognize that functional suitability is an external property of the product, as it can be observed from a black box perspective of your product. Functional suitability has a strong impact on quality in use. If you are new to these concepts, I've linked the first video below. Functional suitability has three main parts or sub-characteristics. These are completeness, correctness, and appropriateness. In the next few minutes, we'll analyze them one by one. We'll look at how they can be properly designed and tested, and check the most important metrics you should consider. Functional completeness in a nutshell is about functional coverage. Does your software include all the functions it's supposed to? So completeness is all about making sure nothing is missing. For example, in a headlights ECU, completeness means the system provides all expected functions. Turning the headlights on and off, switching between high and low beams, and so on. If one of these is missing, the system is functionally incomplete. To achieve completeness, you have to consider all your stakeholders. You can't forget any stakeholder. For example, you must consider laws and applicable norms, because they can directly affect your product's functionality. Furthermore, you have to consider all their requirements for the expected functions. And you must know which functions belong to which software release. This is typically documented in the release plan, also known as feature backlog, product roadmap, and so on. At this point, you are on the top left side of the V model. Stakeholder requirements and release plan are input for the software engineering processes. Finally, you have to provide evidence that the expected functions are also made available in software. Typically, you will check that the release documentation is in line with the expectations of the release plan. Of course, software testing is important to confirm that all expected functionalities have been implemented and tested. Test reports are an input to create the software release documentation. Let's talk now about metrics for completeness. We use the release plan as a primary source for metrics. Examples of metrics are implemented feature coverage per release, that is the number of implemented features divided by the number of planned features. Past feature coverage or failed, that is the number of past features divided by the number of required features. Past or failed change request coverage, this is the number of past change requests divided by the number of required changes. Here are the key takeaways for your project. Don't forget any stakeholder. Make sure you have a complete set of requirements for each software release. Review the release plan with your customer to ensure its correctness. Provide evidence that all functions have been implemented. Let's talk now about functional correctness. Functional correctness is about making sure the software behaves exactly as expected. For example, in a headlights ECU, correctness means the lights react exactly as expected. The high beams turn on when requested, the ECU switches correctly between high and low beams, the system never activates the wrong lights at the wrong time, and so on. In short, the ECU must always produce accurate and predictable results. To ensure correctness, you first need to know which functionalities or features you must implement. Then you have to have a full set of software requirements, consistent, that means correct and complete, with the stakeholder requirements. Second, you must ensure that the expected behavior of the software, expressed by software requirements from a black box perspective, is also reflected in behavior of the software components that are defined in the software architecture. Furthermore, the design specification of the software units that implement the software component, as described in the detailed design, must be consistent with the software architecture. The detailed design will then guide the construction of software units, that is, the construction of the code. Of course, the code must be consistent with the detailed design. Everything at these levels must match the expected behavior stated in the software requirements. After that, testing, unit test, integration test, software test, will verify that the software behaves as expected at the corresponding level of integration. Now you understand that if the design itself is wrong, no amount of testing later can guarantee correctness. Even software testing alone is not enough, because with black box testing you won't achieve a good coverage. And this brings us to one of the key lessons of this video. To ensure functional correctness, testing alone is not enough. You also need to make sure your design is correct, and the completeness and correctness of your design can only be demonstrated through reviews, simulations, prototyping, analysis like FMEA, and similar activities. All these activities have one goal: to show that the design is the right solution to the problem that was described in the requirements. If the design is faulty, functional correctness is at risk, no matter how much you test later. Traceability is the main tool used in automotive software engineering to support the proof of correctness of design, implementation, and test. You can learn more about traceability in a different video on my channel. As you can imagine, there are many metrics related to correctness. We'll explore only a few of them because covering all of them in detail would take hours. But if you are interested in more metrics than the ones that I present here, just leave a comment below. Let's look at some examples. For software requirements, you have to ensure completeness and correctness of your requirements. This means showing that all software requirements are linked to upper level requirements such as stakeholder requirements, and that these links are correct and complete. Nothing is missing, nothing incorrect. Review records are needed to support correctness. In other words, 100% of requirements are traced and reviewed. For software architecture, all components in the architecture must be linked to software requirements. These links must also be complete and correct. The same principles apply to software units, which are derived from the architecture, and to the implementation, which is derived from the detailed design. Traceability and reviews are required to demonstrate correctness and completeness. For testing, unit, integration, and software tests, at every test level, you need coverage reports, that is your horizontal traceability. Every design specification must be traced to test cases. Test cases must be correct and complete, proving that everything is tested, and tested in the right way. This is how the V model supports us in achieving correctness. Here are the key takeaways for your project. Make sure you have all requirements for your release. Make sure your architecture and detail design are fully aligned with the requirements. Make sure your code is fully aligned with the detail design. Verify that software units and software components behave as expected. Test your integrated software to ensure the expected behavior is implemented. Use metrics and review reports as an evidence for correctness. Now let's talk about functional appropriateness. Appropriateness is about how well the software helps users achieve their goals. It's not enough for the software to be complete and correct. It also needs to be useful, intuitive, and effective to the intended users. For a headlights ECU, appropriateness means the driver can easily switch between low and high beams without confusion. Automatic functions like sensor-controlled lights respond in a way that feels natural and predictable. The overall system supports the driver's tasks smoothly without unnecessary steps or surprises. In other words, even if this SU has all required functions, completeness, and performs them correctly, correctness, it's still not fully functionally suitable unless the driver can use these functions easily and efficiently. At the product level, you can't rely on correctness. You also need to evaluate the product from the user's perspective. In a nutshell, this is testing against the stakeholder requirements. If you are familiar with the V model and Automotive SPICE, you know that appropriateness will be tested within the VAL1 process. This is the process that makes sure that the product fulfills its intended use expectations in its operational target environment. In my channel you can find a video on this important process. I leave a link in the description below. Now you should have the big picture. Functional completeness is the foundation. Correctness builds on completeness. And appropriateness builds on both correctness and completeness to provide real value to the users. If you like this interpretation, give it a like right now. Here are some examples of tests and metrics for appropriateness. Task coverage. You verify that the product provides all necessary steps to complete the intended tasks. Efficiency and simplicity. You ensure that the product doesn't require unnecessary steps to complete a task. Tasks should be as straightforward as possible. Metrics, step per tasks, time to complete the tasks, etc. User-centered evaluation. You conduct usability tests or simulations to observe real users performing tasks. Ask, does the product help users accomplish their goals effectively and efficiently? Collect feedback on pain points, confusing steps or delays. Here are the key takeaways for your project. Always evaluate your software from the user's perspective. Ask, does this function actually help the user achieve their goals easily? If the answer is no, you need to improve appropriateness, even if the system is otherwise complete and correct. Now, let's talk about agile development and how it affects functional suitability. Agile is all about iterations and incremental delivery. You don't release the full product at once, you deliver it piece by piece. This is great for flexibility, but it also means we need to check functional suitability in every sprint, not just at the end of the project. In a nutshell, this is about repeating the whole process at every iteration. Let's break it down for our headlights SU. Completeness. Each sprint may implement only part of the SU functions. Maybe automatic high beams this sprint, high, low switching the next. You need to track which functions are implemented and which are still pending, so nothing gets forgotten. Think of your product backlog as a roadmap for completeness. Correctness. In every sprint or increment, you must be sure that the design is correct, and you have to perform unit tests, integration tests, requirement tests, or regression tests to make sure that functions behave exactly as expected. For example, the automatic high beam function must switch on and off correctly in every scenario. Appropriateness. Agile gives you a big advantage here. Frequent demos and stakeholder feedback. You can check if the functions are truly helping users. For this you might ask, does the driver find the automatic lights intuitive and reliable? Are the controls easy to use? So here are the key takeaways to ensure functional suitability in Agile. Treat each sprint like a mini V model cycle. Requirements, design, implementation and test. Keep full traceability. Link user stories to requirements, architecture, design, code and test cases. Use metric to track completeness, correctness and appropriateness incrementally, so nothing is left to chance. Now let's talk about some of the most common pitfalls I see in consulting and assessments, and more important, how to avoid them. Incomplete stakeholder list. Many projects forget key stakeholders, like internal teams or departments. One example, platform development. Create a list of stakeholders at the start and make sure that their needs are captured in the requirements. Incomplete release plan. Often feature release plans are incomplete or not agreed upon with customers or internally. Recommendation: if you don't know where you want to go, you won't be able to get there. Share and agree your release plan with customer and internally. Incomplete requirements. Stakeholder requirements are not consistently transformed into software requirements. Incomplete, ambiguous or inconsistent requirements lead to gaps in functional suitability. Recommendation: invest time in requirements engineering. Make sure each requirement is clear, measurable and traceable to stakeholders. Neglecting traceability. Without traceability from requirements to design, implementation and tests, it's hard to show that every function has been implemented correctly. So recommendation, keep the traceability throughout the project. Even in Agile, map user stories to architecture, design and test cases. No detailed design. Code is directly derived from requirements with no proper functional decomposition and design. Recommendation, don't accumulate technical debt. Design today for a better life tomorrow. No integration tests. Internal interfaces among software components are not consistently tested. The result? Unpredictable behavior under specific conditions, like faults, edge cases, etc. Recommendation: document interfaces and provide a coverage report showing that all interfaces have been properly tested. Lack of consistency. For time reasons or resource constraints, reviews are not performed, and requirements, design and tests are inconsistent with each other. The result? Functional correctness is impacted. Recommendation: verify early and often, from design reviews to unit and integration tests, to catch issues before they grow. You know some more pitfalls? Share them in the comments. Now we are ready for the checklist. Here are 10 questions that you can use in your project. Stop the video for a moment and take your time to read them carefully. We have reached the end of this video. By now, you have learned what functional suitability is, how to design for it, and how to verify it. You also got an overview of common pitfalls and a practical checklist to avoid them. In the next video, we'll continue by exploring another important characteristic of the software: maintainability. Thanks for now, and arrivederci!